Hello everyone, and welcome back to Reverse Engineering Linux 32-bit applications. In this video, we are going to continue our discussion of malware, and in particular, we will talk about using Evans Debugger to examine some malware. So let's go ahead and get started. So I have my Ubuntu sandbox up and running. I'm going to go ahead and full screen that. And let's run our debugger. So I'll just go ahead and pull up a terminal. And I will go to my directory. And we'll bring up one of our suspected bad binaries. So I'm going to go ahead and run Evans Debugger. Now, as a reminder, if you don't know how to use it, you can always try to run it with a -- help option. And here I can run it and just give it a program and any arguments that it might need. So I will run edb -- run. And I would like to run xingji bind shell. And here we go. I have my output here. And here I have my main window for my tool. So let me go ahead and change my preferences, make this a little bit more viewable. Like so. All right, so here we have our different windows. We have our registers over here. We have our stack, a data dump section. Right now it's pointing at the start of the file. You can see the ELF and the 7F at the very start of the file. We've talked about that in some previous videos. I go to my plugins, analyze, now I've analyzed my different regions, and I get this display on the top, where it's going to show me my different memory segments. And I could go ahead and do a number of things. Remember, I can view my memory regions, and this will show me things like the start of my executable. So this segment is readable and executable. Then when I have readable and writable, this is one of my data segments. My stack space, etc., etc. So if I go here, this is going to take me to my program. I can analyze this viewed region. And this will show me my different functions, and it'll subdivide them and all of that. So let me go ahead and let me just step into my program and start running it. So this is my standard preamble for my program. And now I'm going to jump to the start of my program. So you'll notice this is the start, and it's calling to call libc start main, etc., etc. So I can go ahead and keep on stepping. And pretty soon I will be into my program. And here I went a little too far because it died on me. Right? And we talked about that before. If you needed, say, a command line argument and things like that. So let me go ahead and do this. I will stop it. And I will rerun it with my password. And I'll once again do some analysis. And here we are, getting ready to actually get started on this program. So let me analyze this region. Seems to be unhappy with me. Try this one more time. Let's restart. And now we'll run our analyzer. And we'll go ahead and step forward. So again, we have our preamble code. we're going to call start main at PLT. So let's step into that. So we're in some more library code, and then here, very soon, we will be back into our actual program itself. And here we go. Let's go ahead and set a breakpoint here for future. And now I can start stepping through here. And I can start analyzing this code using some of the techniques that we've talked about so far. So here you can see I'm going to call nmalloc. So I'm allocating some memory. Now you'll notice that this nmalloc is a local function. So I could step into it and see what this is about. And here it is. And you'll notice that this ultimately is going to call the actual malloc. So recall when you see at PLT, that's for the procedure table. So here I'm calling the actual malloc. And then you can see I'm going to call memset. So I'm copying some values there. Then I have a leave return. And now I'm back. And then I have put car. Put car will put things out to the screen. P open, etc., etc. So I can easily trace the flow of my program using this tool. So what are some of the other things that I can do with this tool? I can analyze the different regions, which I've done. That shows me the different functions in those groupings. I can look at the call stack as I'm running it. I can look at the header. So here's the header. And it's already displayed down here. It shows the ELF64 header. Tells me a little bit more about the executable. This is the same information that I can get with the file command. It's just inside of EDB. And it seems to be unhappy with me today in running some of my plugins for some reason. I can search for binary string. You know, if I was doing something different from reverse engineering malware, this could be really helpful. It still could be helpful. You know, perhaps I'm looking for certain keywords inside my executable. Of course, I could use strings for that as well. I can manage my breakpoints. I can check for new versions of this tool. I can bring up my error console, dump my current state function finder. So let's go ahead and run this, and you can see what it does. So I can take this region and I can say, please graph it. So first I want to find, and now it will give me a list of functions in this region. Again, this can be very helpful. It will show me what kind of things are being called in this region. Calling put car or set sock opt and some other functions. So all the ones that have at PLT are being called externally, and the ones that aren't will be internal functions or functions unique to this executable. And if I choose, I could go ahead and graph one of these. So let me go ahead and just randomly select one. We'll say nmalloc, graph selected function, and here it is. So now I have a map that shows me the flow of that function, which can be useful. So that's a function finder. Heap analyzer, I can look at different parts of the heap. I can look at the registers in a slightly different view. It says OllyDB-like register view. Opcode searcher. If I'm doing something like a jump ESP or some other opcode that I'm searching for, I can use that tool. I can look at the process properties. I can look at how many threads are running and which modules are being loaded, etc., etc. ROP tool. You might recall what that means. The ROP tool is used for return-oriented programming. So it will look at various gadgets, and I can tell it where I would like to search for gadgets. Again, you don't want to search for gadgets in an address space that's going to start with a bunch of zeros. So you're going to want to look in something like one of these libraries. So here would be a good one. Let's say I want to find in here some gadgets. Reference searcher. Find out who's calling or referring to a certain address. So you want to find out who is using a certain function or variable. Symbol viewer. If I have not stripped my executables, this will show me all of the different symbols. So this can be very, very useful. And of course, we have our standard views where we can look at our different memory regions. We've done this before many times. In the case of malware, what might you want to look at? You definitely want to look at the code. You might want to look at some of the data regions, especially the ones that have constants in them, such as this one. It's read-only. So you can go ahead and have a look at those as well. All right. So that is a pretty quick introduction to using Evans Debugger in order to examine some suspected malware on the 32-bit Linux executables. So, and that's pretty much all I had for this particular video. Just as a reminder, these videos are part of a large family of videos that you can find at Pen Tester Academy, your source for all things InfoSec. And I look forward to seeing you in this course or another course soon. See you then.